It's the treat that knows no season, a universal symbol of joy, a perfect scoop of ice cream. But have you ever wondered about the industrial power and scientific smarts it takes to create this simple pleasure on a global scale? With the worldwide market valued at over $76 billion and consumption reaching well over 18 billion liters annually, the demand is staggering. To meet it, a hidden world of mega factories works 24/7. We're about to pull back the curtain on a state-of-the-art facility where automation, robotics, and food science come together. This is the complete journey of ice cream, from raw dairy to the frozen pint in your local store, revealing how thousands of gallons are churned out every single hour. Chapter 1. The Foundation, Raw Ingredients. Every scoop of ice cream, no matter the flavor, starts its life as a flood of pure liquid ingredients. The journey begins here, at the factory's receiving bays, with the daily arrival of massive tanker trucks. These stainless steel giants are the lifeblood of the operation, delivering thousands of gallons of fresh milk and cream. The scale is immense. A single factory can take in enough milk to supply a small town, all before most of us have had our morning coffee. But not one drop gets inside without passing a strict quality check. A technician snags a sample from each tanker and hustles it to the on-site lab. Here, a rapid-fire series of tests checks for purity, butterfat content, acidity, and overall freshness. This is non-negotiable. Only the highest quality ingredients get a green light. Anything less is immediately rejected. After all, you can't make great ice cream without great ingredients. Once approved, powerful pumps roar to life, pulling the liquid gold from the tankers into a web of pipes. This milk and cream travels to towering storage silos, some holding tens of thousands of gallons. These gleaming towers are the reservoirs for the entire production line, ensuring a constant, steady flow. It's a carefully managed inventory system based on the first-in, first-out principle, guaranteeing the freshest ingredients are always used first. Chapter 2. The Art of the Base Mix. With the dairy safely stored, it's time to create the ice cream base mix, the blank canvas for every flavor. This happens in enormous, jacketed vats. These aren't just giant mixing bowls, they're sophisticated machines. The jacket is a second wall where heated water circulates, gently warming the ingredients as they blend. First, the liquids are piped in. Precisely measured milk, cream, and sometimes liquid sugars like corn syrup. Then giant mixers start churning, creating a vortex in the vat. As the liquid swirls, the dry ingredients are added in a carefully timed sequence. Bags of sugar, milk powders, and other components go in. Sugar does more than just sweeten the deal. It's crucial for texture, lowering the mix's freezing point to keep it from turning into a solid block of ice. Next come the unsung heroes of ice cream: stabilizers and emulsifiers. Stabilizers, often from natural sources, prevent large, crunchy ice crystals from forming. Emulsifiers help the fat from the cream and the water from the milk to get along and bind together. While traditional recipes used egg yolks, modern factories typically use plant-based emulsifiers like mono and diglycerides for efficiency and consistency. Without these, the ice cream would be an unstable, separated mess. This whole ballet is conducted by a central computer. An operator watches screens displaying the exact weight of each ingredient, the mix temperature, and the mixer speed. Nothing is left to chance. The goal is a perfectly uniform base, where every drop is identical. Chapter 3. The Science of Smoothness. Pasteurization and homogenization. Once perfectly blended, the base mix undergoes a two-step process that's invisible to the eye but absolutely vital for safety and texture: pasteurization and homogenization. The mix is pumped into a maze of pipes leading to the pasteurizer. In mega factories, this is usually a high-temperature, short-time HTST system. The mix flows between stacked steel plates with hot water on the other side, allowing for incredibly fast heat transfer. It's rapidly heated to about 80 to 85 degrees Celsius and held there for just a few seconds. Around 25 seconds is common. This is hot enough to eliminate any harmful bacteria without cooking the flavor out of the mix. It's the factory's ultimate food safety guarantee. While it's still hot, the mix is immediately sent to the homogenizer. This is where creaminess is born. Under a microscope, you'd see tiny fat globules from the cream floating in the mix. Left alone, they'd clump together and separate. The homogenizer prevents this by forcing the mix at high speed through an incredibly small valve. This violent journey shatters the fat globules, breaking them down into microscopic particles that disperse evenly and permanently. This ensures every bite will be smooth, rich, and creamy, with no hint of greasiness. Chapter 4. The Waiting Game, Aging the Mix. After the heat of pasteurization and the pressure of homogenization, the mix needs to chill out. This quiet but crucial step is called aging. After being quickly cooled to around 4, the mix is moved to massive refrigerated aging tanks. Here, it will sit and be gently stirred for at least 4 hours, though often closer to 4-8 hours in high-efficiency plants. This isn't just a pause, it's a period of transformation. At a molecular level, a few key things are happening. First, the flavors are mingling and maturing, creating a deeper, more complex taste. Second, the milk proteins and stabilizers are hydrating, absorbing water to further guard against ice crystals. Most importantly, the fat that was shattered during homogenization begins to crystallize. This partial crystallization is essential, allowing the fat globules to form a delicate network within the mix. This network is what will trap the tiny air bubbles added during freezing, giving ice cream its light structure and body. Rushing this step would lead to a thin, weak, or grainy final product. In the quiet cold of the aging tanks, patience is the secret ingredient. Chapter 5. The Flavor. Infusion. After its long, cold rest, the aged base mix is a blank slate, ready for its transformation into an endless variety of flavors. This is where the factory's output splits from one uniform stream into dozens of unique products. The neutral base is pumped from the aging tanks through a complex switchboard of pipes into smaller flavoring tanks. This is where the ice cream gets its identity. For classic vanilla, high-quality vanilla extract is blended in. For chocolate, a rich cocoa liquor turns the pale base into a decadent brown. For fruit flavors, concentrated purees and extracts are added. The factory can whip up a huge array of flavors at once. One line might be making strawberry while another is making mint chocolate chip. It's a highly automated process. An operator selects a recipe, and the system automatically measures the right amount of flavoring into the tank. Powerful mixers distribute it evenly without disturbing the delicate structure that was built during aging. From here on out, what was once a single product is now a whole family of distinct ice creams, each heading down its own path. Chapter 6. The Magic of the Mix-ins, Inclusions, and Ripples. What's ice cream without a chunk of cookie dough, the crunch of a toasted nut, or a swirl of thick caramel? This next stage is where the ice cream gets its personality through additions called inclusions and variegates. As the flavored mix travels toward the freezer, it passes through an ingredient feeder. This machine is basically a hopper filled with solid goodies: chocolate chips, brownie bits, candy pieces. The feeder has an auger that gently and precisely injects these inclusions into the stream of ice cream, ensuring they're evenly distributed without getting crushed. At the same time, flavors that have swirls of fudge, caramel, or fruit get a visit from a ripple pump. This machine injects thin streams of thick syrup, the variegate, into the ice cream flow. The nozzles can be adjusted to create everything from delicate lines to thick, rich ribbons. As the ice cream and ripple move forward, the motion gently folds the syrup in, creating those beautiful swirls you see when you open a container. Through this combo of feeders and pumps, a simple vanilla base can become a masterpiece of flavor and texture. Chapter 7. The Big Chill, Continuous Freezing and Aeration. This is the moment of truth, where liquid mix officially becomes ice cream. The fully flavored and loaded mix is pumped into the heart of the operation, the continuous freezer. This is a refrigerated cylinder with a rotating dasher inside covered in sharp scraper blades. As the mixie enters, it hits the freezer walls, which are chilled to a brutal 30 degrees C to 40 degrees C. A layer of mix instantly freezes to the wall, and the rotating blades immediately scrape it off. Speed is everything here. The faster the ice cream freezes, the smaller the ice crystals will be, and small crystals mean a creamy texture. Slow freezing would create a grainy, icy product, but something else is happening simultaneously: aeration. As the dasher churns, the freezer injects a controlled amount of air into the mix. This is called overrun, and it's what gives ice cream its light, scoopable texture. Without air, ice cream would be a dense, hard-to-eat brick. The amount of overrun is a key part of a product's identity. More overrun means a lighter, fluffier ice cream, while less overrun creates a denser, richer product. The ice cream emerges from the freezer in a semi-solid, soft-serve state. Only about half the water is actually frozen. It has the shape and consistency for packaging, but its journey isn't over yet. Chapter 8. The Automated Assembly Line, Filling and Packaging. As the thick, semi-frozen ice cream flows out of the freezer, it enters a whirlwind of automation. The filling and packaging lines are where high-speed robotics take over. For classic tubs, the process is a blur. Empty containers are fed onto a conveyor and positioned perfectly under a filling nozzle. An automated filler dispenses the exact amount of ice cream at a rate of hundreds of tubs per minute. A robotic arm immediately places and seals a lid on top. Novelties are even more complex. For cones, a machine might first spray the inside with chocolate to keep it from getting soggy, then fill it with a signature swirl. For ice cream bars, the mix is pumped into thousands of molds on a moving track. A machine inserts the sticks, and the track carries the molds through a blast of frigid air to solidify them, so the robotic arms then extract the bars, which might get dipped in a chocolate curtain, before being individually wrapped. Some of these lines can handle up to 20,000 molds per hour. Ice cream sandwiches follow a similar path. A depositor extrudes a perfect rectangle of ice cream onto a wafer. A robot places the second wafer on top, and the sandwich is immediately wrapped. Throughout this stage, printers code each package for traceability, and robots bundle and box the individual units, all without a single human hand touching the product. Chapter 9. The Deep Freeze. Hardening. The packaged ice cream, while formed, is still too soft for storage. It now enters the final, critical freezing step: hardening. The goal is to freeze the remaining water as fast as possible to lock in that smooth texture and prevent large ice crystals from forming later. The packaged products are whisked by conveyor into a hardening tunnel or blast freezer. This is one of the most extreme environments in the factory, a massive, insulated tunnel where temperatures drop to between 30 degrees and 40 degrees Celsius. High-velocity fans create a bone-chilling wind that strips heat from the products with shocking efficiency. The conveyor moves slowly through the tunnel, the speed calibrated to ensure that by the time a product comes out, its core temperature has hit at least 18 degrees Celsius. This can take anywhere from 30 minutes for a small bar to several hours for a large tub. This process freezes most of the remaining water, making the ice cream firm and stable for the long haul. Hardening is the final act of creation that turns the soft serve into the solid, dependable treat ready for its journey to your freezer. Chapter 10. The Guardian of Quality. Automated quality control. Even in a factory this automated, quality is constantly verified. As the hardened products emerge from the freezing tunnel, they face a final gauntlet of high-tech inspections. First up, a check weigher automatically weighs every single package. If a tub is even slightly off, a pneumatic arm gently pushes it off the line. Next, the products may pass through an X-ray machine or metal detector, a critical safety step to find any potential physical contaminants. AI-powered vision systems are also on patrol. High-speed cameras scan each package, checking for bad seals, crooked labels, or unreadable date codes. These systems can inspect hundreds of items a minute with a consistency no human could match. But there's still a human touch. Quality control technicians periodically pull samples for sensory testing. They taste the product, checking its flavor, texture, and appearance against the company's gold standard. This blend of tireless automation and expert human oversight ensures only perfect products make it out the door. Chapter 11. Boxing, palletizing, and warehousing. The final leg of the journey inside the factory is preparing the ice cream for the outside world. The individual products are fed into automated machines that group them into cardboard cases or shrink-wrap them into multi-packs. These cases then travel to the end of the line for a final display of robotic strength. Automated palletizing. Huge robotic arms lift the cases and stack them onto wooden pallets, following a pre-programmed pattern for maximum stability. Once a pallet is complete, an automated wrapper secures the load in plastic film. In the most advanced factories, what happens next is also fully automated. An automated guided vehicle, or AGV, a robotic forklift that navigates using lasers, glides in, picks up the pallet, and whisks it away into the cold storage warehouse. This warehouse is a colossal freezer, often the size of a football field, kept at a constant, frigid temperature where automated cranes manage a vertical city of ice cream. Chapter 12. The Cold Chain. Distribution. The final act is distribution, but you can't just ship ice cream in any old truck. It requires maintaining an unbroken cold chain, a promise to keep the product at a stable, frozen temperature, from the factory to the grocery store freezer. When an order comes in, the automated warehouse retrieves the correct pallets and brings them to a sealed, refrigerated loading dock. A refrigerated trailer backs up and creates an airtight seal, preventing any warm air from touching the products during loading. The pallets are loaded into the pre-chilled trailer, which maintains a temperature of 18 degrees Celsius or colder for the entire journey. This obsession with temperature is critical. Any significant fluctuation, known as heat shock, can cause partial melting and refreezing, which would destroy the smooth, creamy texture the factory worked so hard to create. From the factory, this fleet of mobile freezers fans out, delivering the final product to stores, where it awaits its final trip into your shopping cart. So, the next time you open a carton of ice cream, take a second to appreciate the incredible journey it's been on. What starts as simple milk and sugar is transformed by immense scale and microscopic precision. It's heated for safety, pressurized for smoothness, and aged for character. It's infused with flavor, studded with goodies, and whipped with air. It's flash frozen in a steel vortex, packaged by an army of robots, and hardened in a polar blast. From the tanker truck to the hardening tunnel, the modern mega factory is a marvel of engineering, a non-stop dance of science and automation. It's a process that turns basic ingredients into a beloved treat, proving that behind the simplest pleasures often lies the most extraordinary process. If you enjoyed this look inside the factory, be sure to like this video and subscribe for more amazing manufacturing processes. What's your favorite ice cream flavor, and what surprising inclusion would you love to see in your next scoop? Let us know in the comments below.